Welcome back to Mr. Hassan's Maths channel. I have a question here which has been requested by one of the viewers. Question number 12 from June 2018, the C12 paper, C12 paper, International A-Level. It's a question about trigonometry, and I'm going to go through this in a little bit of detail so that we get some of the ideas from this topic covered. So basically this question is telling us to solve for values of x between 0 and 360 degrees, where 0 is included and 360 is not. The equation 5 sine of the angle x plus 65 degrees plus 2 equals 0, giving your answers in degrees to one decimal place. Okay, so we have to first of all rearrange this so we make the sine of the angle the subject of this equation, so we can subtract 2 from both sides first. So we have 5 sine x plus 65 degrees is equal to minus 2, and then divide both sides by 5. So you have sine of the angle x plus 65 degrees is equal to minus 2/5. Okay, so now we have this in a form that we can just find the angles which have the sine ratio of minus 2/5. But what we have to be careful of is the following. We have to make sure that our limits, okay, which are from 0 to 360 degrees, okay, look, the angle in the limits looks exactly like the angle that we're trying to find the sine ratio of. So here is sine of the angle x plus 65. So this should say x plus 65. Now, if I change one part of the inequality, like this middle part, I've got to change the other. So whatever I did to this, I must do to the two limits. So this is going to be 0 plus 65, which is 65 degrees. And this is going to be 360 plus 65, which is 425 degrees. Now, it's very important I do that so that I don't miss any of the solutions. If I leave it like this, I might miss some solutions which are actually going to become in our range once we've adjusted the answer at the end. Or I might leave out some solutions that might end up being in our range. Okay, so it's very important that we do this. It's very important that we basically change this limit to make it look exactly like what's in here. Okay, and then of course the outer limits will change in the inequality. All right, so now we're going to find what angles have the same sine ratio of minus 2/5. So we're going to use our calculator, inverse sine of minus 2/5, and the calculator will give us the principal angle, which has minus 2/5 as its sine ratio. So you go to your calculator and you make sure that it's in degree mode. It looks like it's in radian mode, so in this calculator, this is how you do it. You press the shift button and this menu button, and you go to angle input and you change it to degrees. We need it in degrees. Okay, and then you put inverse sine of minus 2/5, close the bracket, and that gives you what's called the principal solution, minus 23.578. So minus 23.578. They asked us to write it to one decimal place, but I've written it to a few more. In the end, I'm going to round it to one decimal place once I've got all my solutions ready. So minus 23.578 is what's called the principal solution. Now that solution is actually outside of our range. However, you don't get rid of it right now. Okay, we're not going to write it in our final answer. We're not going to use it in our final answer. What we're going to do is we're going to first find all the other solutions which are in our range, and we need this angle to do that. So for the sine ratio, for the sine curve, basically to find the other angles, you've got two main angles. One is the calculator answer, and the other is always 180 minus the calculator answer. So if we do 180 degrees minus 23.578, that becomes 180 plus 23.578, which gives you 203.578. Okay, that's like the other main angle. So these are the two main angles. Okay, so basically if we think about the sine of an angle, this is a sine curve. So the sine of an angle being minus 2/5 is down here. That's y equals minus 2/5. See, we found one angle over here, which is actually the angle we found was this angle here. Okay, this is the angle that the calculator gave us, which is minus 23.578, and it's outside of our range. Okay, and the other angle we found was here, which is basically, if this is 180, this is 180 plus 23.578, which is given by 180 minus 23.578. So that's the other angle we found. Now we can see there's another angle here, which also is going to be in our range. So how do we find that angle? Well, basically what we know is that the sine curve repeats itself every 360 degrees. So this angle is going to repeat, okay, 360 degrees away from here. So to find all the other angles, okay, once you've got the two main angles, which are 203.578 and minus 23.578, you just have to take these angles and add 360 to them and subtract 360 from them until you're outside of the range. Now, of course, if I add 360 to this angle, if I do 360, let me do it this way, it's better. If I do minus 23.578 and I add 360 to it, I'm going to get the angle over here. So it's like doing 360 minus this, 360, plus that. Okay, which gives you 336.422. 336.422. 336.422. So we have an angle here, an angle here, and an angle here. Now this is outside of our range, but I used it to find this angle, and I also used it to find that angle. Any other angles, like if I add 360 to this angle, I'm going to be outside of the range. If I take away 360 from this angle, I'm going to be outside of the range. If I take away 360 from this angle, I'm going to be out of the range. So these are the two angles which are in our range, the two angles over here. Okay, so it's these two angles here. So I have to now adjust because of the this x plus 65. So it's not x that is equal to 203.578, it's x plus 65. Because we found the sine of this angle here. It's the sine of this angle x plus 65, which is minus 2/5. So we saw x plus 65 is equal to 203.578, and also it's equal to 336.422. Those are the two angles that we need. So to find the value of x, we're going to subtract 65 from both of these angles. So we're going to have, let's start with this one, minus 65, which gives us 271.421. Okay, 271.421. Whoops. So you have 271.421, and you have 203.578 minus 65, which gives 138.578. So you have 138.578. Let me just make sure I covered that right. Yep. Okay, so those are our answers, but we have to give the answers in degrees to one decimal place. So now what I must do is round these to one decimal place. So that's 138.6 degrees and 271.4 degrees, and those are our solutions to question 12 part 1. Okay, so that's with the sine ratio. Now for part 2, there's a bit more to it. First, you have to we've got to solve this equation from 0 to 2 pi. So now we're going to deal with radians. Okay, so the first thing you should do, in case you forget, is to take your calculator and change it now back into radian mode. So that's option 2 here. So now the calculator is in radian mode. Okay, so whenever you use trigonometry with radians, you must make sure you change your calculator to radian mode. So now, you got 12 sine squared plus cosine 12 sine squared theta plus cosine theta equals 6. And we're going to find all the solutions between 0 and 2 pi and giving the answers in radians to 3 significant figures. So this equation first, we have to try to modify it so that it can be solved easily. So we've got 12 sine squared theta plus cosine theta equals 6. Now, in order to solve this equation, what we need to do is to change them so that they're both expressed in the same ratio. So I've got sine squared and cosine, so I can make them both into sine squared, or I can make them both into cosine. Both in the sine ratios or both in the cosine ratios. Now, because we have a very useful identity, which is sine squared theta plus cosine squared theta equals 1, using this identity, I can switch between sine squared theta and cosine squared theta very easily. Like if I want to express things in terms of cosine squared theta, I can replace the sine squared theta with 1 minus cosine squared theta, just rearranging this. And if I want to change things in terms of sine squared theta, I can take the cosine squared thetas and make them into 1 minus sine squared thetas. Now, so the one that is squared is the one that's easier to change. To change cosine theta, okay, I can't do it. This only applies to sine squared plus cosine squared theta equals 1. It doesn't apply to sine theta plus cosine theta equals 1. You can't say that that's the same. So sine theta plus cosine theta does not equal 1, but sine squared theta plus cosine squared theta equals 1. So they have to be squared for you to use this identity to change them. So to change the cosine theta won't be so easy, but to change the sine squared theta, as you can see, I can make the sine squared theta into 1 minus cosine squared theta, and then I'll have them all with the same ratio. So let's do that. Let's do 12 times, instead of sine squared theta, I'm going to write 1 minus cosine squared theta. Then I've got plus cosine theta equals 6, and then I can expand. 12 times 1 is 12, minus 12 cosine squared theta plus cosine theta equals 6, and I can bring everything to one side. So I've got minus 12 cosine squared theta plus cosine theta, and 12 minus 6 is plus 6 equals 0. And as it's a quadratic type of equation here, it's cosine squared and cosine, I'd like to make this part positive, so I can write this as 12 cosine squared theta. I'll just multiply everything by minus 1, so that'll be minus cosine theta, and minus 6 equals 0. And just to make life a bit more kind of friendly, let's call x equals cosine theta. So let's change the cosine theta for x. So this is going to be 12x squared, because cosine squared theta is actually, that's what it means, cosine theta squared. So this is 12x squared minus x minus 6 equals 0. Now we could try to factorize this and solve it. So let's try to factorize it. Just use our window method here. So we need to find two numbers. They multiply to give us, got 12x squared minus 6, which is going to be minus 72. So the product we have to find is minus 72x squared. And the sum we have to find is the same as this, which is minus x. So what two numbers multiply to give us minus 72x squared, and they add up to give us minus x? Well, it looks like it's minus 9x and plus 8x. 9x is 72, and minus 9 plus 8 is minus 1. Yes. So let's now take the factor from these two terms. That's 4 and x. And from these two terms, it's 3 and x. 4x times plus 2 is 8x, and 3x times minus 3 is 9x. It looks like that's correct. So you're going to have 4x minus 3 times 3x plus 2 equals 0. Let's just make sure that's 12x squared plus 8x minus 9x. That's correct. And minus 6. Good. Okay, so we can solve each of these. So we can say 4x minus 3 is 0. That means x must equal 3/4. And 3x plus 2 is 0. So x must equal minus 2/3. So now we know x is equal to cosine theta. So we can say that means cosine theta is 3/4. That'll give us some solutions. And cosine theta equals minus 2/3. Okay, good. So both of these will give us solutions. Sometimes you get the situation where you end up with cosine theta equals a number which is bigger than 1 or less than minus 1, in that case, that will generate no solutions, because the sine and the cosine curves, the cosine curve goes like this. They don't go above 1 and they don't go below minus 1. So if it's not within that range, you won't get a solution. Okay, tan is finest. Tan will continue for infinity both ways. But anyway, cosine theta equals 3/4. So we want to find the angles which have the ratio of 3/4 and in radian form. So inverse cosine of 3/4. Now, as I mentioned before, the calculator gives us what's called the principal angle. Okay, the principal angle. So the principal angle here, you press inverse cosine of 3/4, positive 3/4. Okay, and that is what's called the principal angle, which is 0.7227. So 0.7227. That's the first angle in radians. That's called the principal angle. Okay, now what we're going to do here, just to be clear, that we have our limits between 0 and 2 pi. So I'll write that here. The limits are between 0 and, was it theta? Yeah, theta and 2 pi. Okay, those were our limits. What I'm going to do here is I'm going to write what 2 pi is in terms of decimals, so that we know when we've gone out of our range. Let me just store this answer as A. Okay, so now I've stored that answer, but 2 pi, if I write this as a decimal, it gives me 6.283. So I'm going to write here 6.283. So I know that's as far as I can go. Okay, I'm going to start from 0, I'm going to go all the way up to 6.283. I can't go further than 6.283. So the principal angle is 0.7227. The next angle, the main angle for cosine, is always 360 minus the angle that the calculator gives us. In this case, we're not going to use 360, of course, we're going to use 2 pi, because we're dealing with radians. So it's 2 pi minus the answer that we had for A. That gives us 5.560, 5.560. So I've written this to more than 3 significant figures, because we need to round in the end. So those are 2 of the answers. Now, if I were to add 2 pi to this answer, I will go outside of my range. Okay, I'll definitely get more than 2 pi. If I do the same for this, I'll go outside my range. If I were to take away 2 pi from this and from that, again, I'll be outside my range, because my lower limit is 0. If I take away 6.283 from both of these, of course, I'm going to go in the negative. So it looks like these are the only 2 solutions. Okay, so just to show you in terms of the quadrants, cosine is positive in the first quadrant and the fourth quadrant, A, S, T, C. So cosine is positive, A and C, these 2. And the angle that the calculator gave us first was this angle here. That's 0.7277. The next angle we need is the angle, because we're only going in the positive direction, so we're going in the anti-clockwise direction, is all the way around over here, which is basically 1 whole revolution minus this angle, because this angle and that have the same magnitude. So it's 2 pi minus the angle we found first. That's how we got these 2 solutions. And if you try to go further on, you'll pass the limit of 2 pi. And if you try to go, backwards, again, you're going to go past 0, the negative side. So those are the 2 solutions for this. Now for the other one, we're going to have theta equals inverse cosine of negative 2/3. In this case, our solutions are going to be in a different quadrant. So here we're going to have theta equals, so let's get the inverse cosine of minus 2/3. Okay, that gives us 2.3005. 2.3005. That's the principal solution. Okay, now what you'll realize here is, in this case, we're finding where the cosine ratio is negative, which is in this and this quadrant. Okay, so the angle that we got first was this angle over here. And we can only go in the positive direction, so the next angle we're looking for is going to be over here. which again you can see it's 2 pi minus this angle, because this angle has the same magnitude on this side. So if I do 2 pi minus this, I'm going to get the angle I need. So it's going to be 2 pi minus the answer here. So I'm going to say 2 pi minus the last answer, which gives us 3.9827. 3.9827. 3.9827. Those are the two answers we're going to get. So basically for the cosine curve, it's pretty simple. What you have to do is you have to take the first solution that the calculator gives you and just do 360 minus that. In this case, 2 pi minus that, because we're dealing with radians. And those will be the two main angles. So these are the two main angles for this particular one. And all the other angles are found by adding 360 to them and taking 360 away from them. So these angles minus 360 and these angles plus 360 will give you all the other angles. However, in this case, all those other angles are going to be outside of our range because we have to stop at 0 and we have to stop at 2 pi. And similarly, even when it's a negative ratio, the first angle that you get will be here, which will be in the second quadrant, and the other angle is found by doing 360 or 2 pi minus the angle, and again those will be the only two angles that we found. Okay, if you want to link them to the curves as well, you can see what happens there, but let me just write the answers down. So I'll just get rid of this now. So I'm going to write down the answers in the format that they required, which is to 1 decimal place. So I'm going to write all 4 answers down. So I'll start with the smallest, which is 0. No, it was 3 significant figures. Yep. So you have 0.723. That's 3 significant figures. And the next one in order of size is 2.30. You have to write the 0 down because that's the third significant figure. Then you have 3.98. Then you have 5.56. 5.56. Those are the solutions to this question part B. Okay, so that's how you deal with these questions. And just let me just quickly show you how that relates to the curve. The cosine curve looks something like this between 0 and 360. Okay, that's 2 pi, and pi is here. And this is 0, that's pi over 2, that's 3 pi over 2. Okay, so the first one was when cosine of the angle is equal to 3/4. 3/4 is somewhere over here, just say, right? It's somewhere up here. So you can see that there's two angles. Okay, so this is the angle that the calculator gave us. And this angle here is the one we found, which is 2 pi minus the angle, because this is symmetrical. All right, that's why you do 2 pi minus the angle. So those are the two angles we found. And cosine of theta equals minus 2/3. Minus 2/3 is somewhere down here. And again, the calculator gave us this answer here first, which is that 2.3005. And again, this distance is the same as this distance. So 360, 2 pi minus this angle here will give us the other angle that we needed, which is 3.9827. So that's how it relates to the graphs. And up here is how it relates to the quadrants. I crossed it out earlier. So I hope that's clear for you guys. And whoever requested the question, I hope that makes you understand the topic better. So be careful not to make a mistake of messing up with your rounding. When you have 0.723, the first significant figure is the 7. That's why I've written three numbers, the 7 and 2 numbers after it. But in this case, the first significant figure is the number 2 and the number 3 and the number 5. That's why there's only 2 numbers after the decimal point. Okay, so there we have the answer to this question. Thank you for watching.